Antarctica, the largest mass of ice on the planet and the largest source of potential sea level rise. How has climate change affected the Antarctic ice sheet in the past? How much sea level rise can we expect, and when? One method to answer these questions is scientific deep-sea drilling, recovering sediment cores from below the seafloor. These sediment cores give a view of the past that might offer clues about the future. Scientific ocean drilling began in the late 1950s as Project Mohole. Project Mohole attempted to drill through the Earth's crust to sample the mantle.
Somewhere down there, the drill may pass through the time and place of life's beginning.
Although the mantle was never reached, Project Mohole did show that deep ocean drilling was a viable means of obtaining geological samples. Fast forward 15 years, and deep-sea drilling goes to Antarctica for the first time, as part of the Deep Sea Drilling Project.
Very special ship, the Glomar Challenger, serves as a floating laboratory to aid scientists in finding out what the changes were, when they occurred, and what they might be in the future.
The Glomar Challenger traveled the world in 96 legs.
This is leg 28 of the Deep Sea Drilling Project. The cores we get will provide the most complete record so far of changes in the Antarctic climate over the last 50 million years. 14 holes, and only 10 weeks to do them.
In 1973, the Leg 28 team found cores near the coast that the Antarctic ice sheet was at least 25 million years old. But the first deep water climate proxy record from Leg 29 indicated it was older, after the Southern Ocean gateways opened to isolate Antarctica.
These first ship-based legs inspired Antarctic geologists to core the seafloor from the fast ice off the coast. First in 1975, then 79, and again in 1984. But real success came with the Syros-1 drill hole, coring back to 34 million years and the earliest ice sheets.
DSDP became the Ocean Drilling Program. Operations moved to the JOIDUS Resolution.
There's the JOIDUS Resolution, the US-based workhorse of the program. This flexible, adaptable vessel has been drilling samples and providing data for nearly 30 years.
Expeditions went back to the Antarctic, with ODP legs 113 to the Weddell Sea and 119 and 188 to Pritz Bay. They found many insights about the evolution of the Antarctic ice sheet over the last 34 million years. But in 1998, Leg 178 was the first expedition to link ice proximal processes and deep water processes. The team discovered the link between changes in ice sheets and ocean currents.
We proved that you can obtain a continuous and relatively high resolution record from the distal continental margin. We also proved that sediment drifts are a good place to drift. And we need to make sure that we get samples. And so no samples without drilling.
Better records were obtained on Leg 178, largely because of advances in technology, like advanced piston coring and better paleomagnetic measurements. Combining diatom stratigraphy with paleomagnetism proved particularly important in dating glacial sediments. At about this time, the sea ice-based Cape Roberts project produced the first cores recording glacial-interglacial behavior of the early ice sheets 34 million years ago. Then came the first ever model showing how early ice sheet fluctuations could be driven by variations in atmospheric carbon dioxide and tiny cyclic changes in solar warming. Then came ANDRILL. In 2006, Antarctic Geological Drilling, or ANDRILL, brought together more than 200 scientists from 7 nations to drill on the ice itself.
We made a hole 84 metres deep, then we lowered our pipe through the ice shelf and a further 850 metres down to the sea floor. And from there we drilled back in time 14 million years through sedimentary layers of rock. We got to the bottom of the hole, we had drilled 1,284 metres of core. We're starting to build a picture of a very different Ross Sea, Antarctica, West Antarctica during some of these warm periods in the past. the West Antarctic ice sheet is a very sensitive feature.
We were seeing many cycles when we had a large glacier here, bigger than we have today, and then we're seeing the disappearance of that glacier and open ocean conditions where I'm standing right now.
ODP further grew into IODP.
Coming soon, IODP Expedition 318, January, February and March 2010.
By building on knowledge gained in the ANDRILL project, Expedition 318 provided a key direct milestone for modelling future global sea level. This expedition proved the East Antarctic ice sheet was not always stable, that in fact, large marine-based sectors collapsed during the superwarm Pliocene interval 3.3 million years ago, as they had from the West Antarctic ice sheet.
What causes this ice sheet to decrease in size? What causes this ice sheet to grow? And this is especially relevant as we have seen more and more in the past 20 years how we have this global warming trend in our Earth. So actually when we put the proposal, it was more of a scientific curiosity, but as time went by, it became a very relevant societal issue to address.
This was the time when we began to have a more comprehensive view of the continental margin architecture and the effects of Antarctic ice sheet dynamics. The Integrated Ocean Drilling Programme became the International Ocean Discovery Programme.
There is no better place to study Earth's climate history than the ocean floor. Scientists have expanded the frontiers of human knowledge by drilling core samples from each of the world's ocean basins. Their work is far from done.
IODP's most recent expedition to Antarctica, Expedition 374 in 2018, made good use of the knowledge gained from all the previous Antarctic drilling expeditions to pinpoint the most effective places to drill. This expedition tackled the questions: what happens at the grounding zone during past superwarm times, in the Pleistocene, Pliocene and Miocene? The grounding zone is where the ice sheet becomes thinner and ends, detaches from the substrate, and starts floating and disintegrating into icebergs. What was the influence of warm water on the continental shelf edge and on the overall stability of the ice sheet? Scientists on board Expedition 374 also included 2 microbiologists. Antarctic bacteria is an important area of study, as it may have a role in regulating global greenhouse gas exchange.
One of the big questions before this expedition was that we didn't really know, when we just elevate temperatures by 1 or 2 degrees, what do the ice sheets do? And I think with these sites now, we have the records to really get to that question.
It's very important to select your site, and seismic can help to determine the drilling depth by calculating the speed of sound in the water and in the sediments.
It answers some questions, but like all science, it raised as many questions as it answered. So we're going to look at going back to the Ross Sea. It's not going to be another 45 years before we do that.
Further scheduled IODP Antarctic expeditions include Expedition 379 in 2019 in the Amundsen Sea and Expedition 382 in Iceberg Alley. Another expedition will return to Wilkes Land through the European Consortium for Ocean Drilling. This will be Expedition 373 on a mission-specific platform, the first in Antarctica, and will work near the coast. These expeditions will open a new phase of incredible discoveries. And there is more to come. The continental margin of the East Antarctic ice sheet is almost completely unknown and needs to be better understood. All of this would not be possible without the funding and organisation mechanisms provided by the Scientific Committee on Antarctic Research and its programmes, along with massive international cooperation.
It's an international, interdisciplinary body of the International Council for Science. The future seems to be one where we're going to see sea level rise, but we're uncertain about how much, and the past can help us to understand that uncertainty.
Collaboration to me is one of the most important aspects. Not only do you collect the data, but you have to trust one another to share it and work with it together. And this is critical if you want to have a good science program.
We have learned much in the past 50 years of Antarctic ocean drilling, but there is still a long way to go. IODP is a unique method of discovery. It is the world's largest and longest-lasting multidisciplinary floating laboratory, where international teams of scientists, technicians and crew work together for 2 months, collecting sediment cores to decipher Earth's history and unlock its future.